Okay, let's demonstrate closure in Go. If you're familiar with JavaScript, you're probably pretty familiar with the concept of closure. Let's declare a function counter, my counter. It will take no variables, and it will return a function. And this function will take no variables and return no value. And inside the body here, let's declare a variable of the count. Initialize it to 0, and let's define a incrementer function. Increment will take no parameters and return no value. And as you may have suspected, it will increment our count. And let's print this out. Go ahead and return increment. And now if we look at increment, again, it's a function that takes no parameters, it returns nothing, and that's exactly what we declared our function myCounter would return. So this should all work. Now in our main function, let's declare a variable increment of type func, set increment equal to myCounter, remembering that myCounter is going to return a function. And let's set up a little loop here. And let's call increment within the loop. We have to put parentheses behind it because it's a function. And run this on the right. And sure enough, this works. Now, if you're not familiar with closure, this might seem a little bit magical. When we declared increment as a function, the scope of this function is actually the scope of the function that it was declared within. So that means the count variable is rolled up into this function and it persists even after myCounter has returned. So even though by the time we get down here to actually calling increment, this function has returned, you might think that the counter would be destroyed when this function was returned, but because it's been rolled up into the scope of increment by the rules of closure, the variable, the count, still persists when increment is called. For the hell of it, let's make myCounter even uglier. I'm going to refactor it slightly. In addition to an increment function, I'm also going to declare a function that just prints the value and returns it. Get will be a function that takes no parameters and returns an int. And in our body, let's declare it also. It returns an int. It does not increment anything, but it does, again, return an int. In this case, the count. So let's make some changes in our main function to accommodate this. Here we've just declared two variables using the convenience operator. And let's print out our final value. And this should be get up here. And let's run this now. And make these changes, since we already declared increment and get within our function declaration. And sure enough, that all worked. So even though myCounter has returned, the count still persists in closure, and it's available to both increment and get, even though I can't directly access it from within my main function. One last thing, this function declaration is getting kind of ugly, and they can get very impenetrable in Go to understand. Let me do some more refactoring. Return increment and get here, and change our declaration this is just a different way to write the same function. Now imagine we pass in a initializer, and run this on the right. As you see, this method declaration can get pretty complicated. Imagine if this also returned a type, and if both of these had one or more parameters, it could get pretty ugly. What we could do is actually declare some more types, such as type inc func type is a function which takes no parameters and returns no parameters, and type get func type is a function which takes no parameters and returns an int. Similar to here and here, we could then in theory just go in and replace our return types with the types that we've just declared. Whether this actually makes this code more readable is questionable, but there are cases when you might want to do that. So save it and run on the right. And again, everything runs as we would expect.